Here in three-dimensional display methods, we are trying to understand, given a three-dimensional object, if we have to display it. So we are displaying it on a two-dimensional monitor. Okay. So is there some way to display it in a so that it should look more real? Okay, so we will go through some of the methods. Before that, let me tell you that we need a reference coordinate. Suppose where the camera is, from where you are looking at the three-dimensional object. So from this position you are looking at the three-dimensional object. So this will give you a reference coordinate system. Okay. So taking a reference from here, you will get a particular view of the three-dimensional scene, and that particular scene only will be displayed. Okay. Having this information, now how will you display these things? Okay. The thing are, these objects, okay, I have kept the image here actually. The objects can be displayed in a wireframe manner. Wireframed. Okay. Okay. Wireframed or wireframe form. This image may not be that much clear, however the same image is given in the book also. So you will understand one thing from here, that it is having the vertices, multiple vertices, connected lines, and only lines are forming, right? So I should say the outline of the object is given here, and this outline is enough to represent your object. Okay. How is it looking like, that is a different thing, but we are trying to understand how it can be displayed. So one thing is, this is the outline given. Okay. Having this outline may be not that much realistic, however it will give you an overview of the object. If you want it to be more realistic, then in that case you will recognize that all these lines, if they are connected to each other, these lines are connected with each other, so somehow they are forming certain polygons. Okay, these polygons you can understand them as surfaces, right? So these surfaces, how to represent them, you already know. These surfaces, if they are shaded with a particular color, okay, if you assign a particular color to this polygon, you call it shading. Okay. So if this particular polygon, I should say the surface, you should understand this with the surface, that if you are able to assign a particular color, if you are able to shade this particular surface, then when all the surfaces will be shaded with the desired color, then the object will look more realistic. Okay. Okay. So till now in wireframe structure, you will have the coordinates of all the vertices, and they will be connected to each other. That means edges will be there, they will be connected to each other, right? Okay. So if you have stored an object with these information, like their vertices and their connections, then you can easily represent an object in a wireframe manner, right? Now we are going towards understanding something, we call it projection. What is this projection? When we think about projection, it is displaying your 3D object on the 2D device. Okay, displaying your 3D object on 2D device. Now if you want to display a 3D object on a 2D device, there is some limitation, right? So there is something called different ways of projection. One is parallel projection. Parallel projection. This is actually an example of parallel projection. So what is happening here in parallel projection, that if this was your object, you can understand this is a 3D object, but you will be able to see this object from any one axis. I should say keeping it parallel to any one axis. So you can suppose this is your front, so you can see it either from the front or from the top or from the side. Okay, so when you will see these from these three perspectives, either from top or side or front, you are looking at from any looking at by keeping it parallel to any axis. Okay, so it may look like it is not giving that much realistic information. However, you can understand this thing, that it is giving us information that how will it look like if we see it from one particular direction. Okay, so this kind of parallel projection is also useful. It may be useful in your some engineering and architectural drawing also, where you may be interested sometimes in looking from one particular angle. Okay, so from that particular angle, how will it look like? It is true that definitely we want to look from an angle, but there is something which is missing. Okay, let me tell you about perspective projection. Perspective projection, in perspective projection, what happens? It is a little bit similar to what actually happens to our eyes, or what actually happens with the lenses in camera. What happens when a camera takes a photograph, or whatever we see, okay, two objects of same attributes. Attributes means height, width, length, whatever attributes of the object is, same object, two objects having same characteristics. If they are, one is at point A and one is at point B, then it will definitely depend if you are seeing these two from here. Okay, in that case I believe I should draw like this. Maybe it will look like an eye. So if you are looking from here, then one thing that you will agree is the object, both the objects are there, A and B, location A and location B. Both the objects O1 as well as O2, they are of same characteristics. However, O1 is near to the viewing point and O2 is a little far. So the object which is little far, which will look smaller. Okay. However, the one which is near will look bigger. Okay. Do you agree? Does it happen? Can you tell me? When you look at a particular scene, wherever you are, something which is near to your eyes, and the same thing if it is on a distance. So when it is near, it looks bigger, and when it is far, it looks smaller. Does it happen?
Yes, sir.
Yes, sir.
Yes, it happens. So the same thing here in perspective projection we try. What we try is the objects which are near to the viewport, or near to viewport is not the correct word, near to the camera, okay, they should look bigger, and those which are far from the camera, they should look smaller. So we already know that camera is giving us the reference coordinate, okay, that from here how far it is and how far the other objects are. So those objects which are smaller, they should look those objects which are far, they should look smaller. The object which is nearer, they should look bigger. Okay. So these are the few things that we have to understand, and this thing is possible with perspective projection. However, in parallel projection, this thing, understanding of depth, was not possible. In parallel projection, you can see it from any one of the parallel axes, and you can get a view which may not be that realistic as it may be in perspective projection. Okay. So suppose this object, one object if at all was here, in parallel projection it may look like this or whatever, which is everything similar. However, in perspective projection, if the camera is on this side, then the front one may look similar. However, the back one may look a little not as it was. Okay, if at all it was like that. Something. Maybe I may not be able to draw it that nice, but you have to understand one thing is that in perspective projection, what is nearer, it will look bigger, and what is far, it will look smaller. That is the thing. Okay. Also, one thing that I can say is about depth, right? Okay, have I said these things, parallel and perspective? No problem. Let us talk about depth cueing. Okay, from the word itself you are trying to understand that here we want to get the depth information. Simple, right? So you will agree that in many systems depth information is very helpful. So what happens, like in perspective projection, you have seen if an object is there, if at all we are able to see that if we are able to see this particular object, so in the front it will look bigger, and in the back, with as the depth goes, with the depth it will look smaller. Okay, so if we have such information related to the depth, it will help us. Now suppose that you have such wireframe object, means with the wireframe is the vertices and the edges, this kind of a structure. If it doesn't have a depth information, okay, then what will happen? If we don't have depth information, then at least what we can do is in the front, if you are keeping a dark I should say color, okay, and in the back you are giving some light color, okay, it is still the same anyway. Now it is black, let it be. So what I am trying to say is, according to the depth, if in the same object you are able to vary the color intensity, then you can represent the depth. Okay, you can give a sense of the depth. As the distance increases, the intensity is changing. Okay, so this is a way. Now one way also can be like if at all it is a wireframe, in that case, as near to the camera it is the vertices are far. However, as depth increases, as it goes far from the camera, the vertices becomes nearer to each other. Okay, that means I should say frequency, right? They all are coming together, means coming nearer to each other. In that case, they also give a sense of this thing, depth. So these are a few methods in which you can represent the depth. Most important is varying the color intensity if at all we are using the color, then color intensity. If it is black and white, then the black and white means grayscale intensity. If you will change this grayscale intensity throughout here, then you will be able to represent the depth. Simple thing. So for depth cueing, the simple solution is to use different color intensities based on the shape of the object. Okay. Okay, let me say something about visible line also. Since we have to see, let us go through it. It is visible line and surface as well. Okay, visible line and surface identification. Okay, which means you will have multiple lines and then you have to decide which one line should be visible, right? So what you need to do, there are multiple lines which are there and you have to decide which line to be visible. In that case, the one option is to highlight the line. Okay, how can you highlight it? You can paint it with a different color, right? So here for line, what you are learning is you can highlight it, highlight the visible line, okay, or you can use a different color. You can use different color for it. Okay, simple thing. You can then distinguish, you can, I should say, you can easily identify the visible line. Okay, another method can also be where you can what you can do, whatever the colors were there, let them be as it is. However, these lines, all the lines are okay, this is the lines, but you can make these lines as a different in a different way, like you can keep, you can make them dashed lines, okay, or dotted lines. Okay, some distinguish you can make from the visible line and the other lines. That may also be possible. Okay. Okay. This was about visible line. However, surface. Okay. For surface, I should say, let me talk about surface. Let me call it surface rendering. When do we call it surface rendering? When a particular surface, whatever the polygon you call, when it is shaded with a color, okay, then okay, when you are giving it a color, you are calling it a shading, right? Now, when you really give it a degree of realism, okay, then you call it surface rendering. Means it may start looking like a real surface. How it is possible? When while shading also you are not assigning the same color to all the pixels on this particular surface. What you are doing, you actually see the I should see is not a good word, I should say consider, right? You consider the lighting conditions as well. Okay, so having known about the camera, you are looking at this, and the light source. Okay, there is a light source which will be falling on the surface. So having this information, and suppose here is your camera. So from here, this surface, how this surface will look like. Okay, having known that light source is here, this light will fall on this particular surface, and accordingly whatever color it was, it will look something from here which will really be different if the camera is here. Okay, so while giving it a particular color, you also understand the lighting condition, as well as you also understand the surface characteristic. What can be the surface characteristic? Means whether it is a smooth or rough, okay, whether it is transparent or opaque, what can be the spelling? Okay, it should be, you can understand, it would be something like this, I believe. So whether it is transparent or opaque, rough or smooth, depending on these characteristics also, there should be a difference in the color, or how this surface should look like. Okay, so just shading it with a particular color is not enough. Now you have to consider the lighting conditions as well as the surface characteristic. If you will consider these two things, then there will be a realism in the display of this surface. Okay, so if this happens, you can call it as surface rendering. Okay, okay, having understood about these few things, surface rendering, do you know about a stereoscopic view? Stereoscopic view. Okay, this is stereoscopic is together. What does this mean? It means that how can you see a three-dimensional object? Okay, my question is it possible, how do you think that you see a three-dimensional object? You as a human being, you see the three-dimensional objects. What do you think? What makes it possible for you to understand the three-dimensional object? Means how are you able to understand the depth here, whatever you are seeing? really, let us discuss a little on it, and then we will move further. What do you think? How do you see how a human sees the depth, senses the depth? It is able to figure out that this thing is near and that thing is far. How does it happen? One thing is clear, you have eyes, right? So my question is, what is the feature of this eye that gives you this thing? I mean, how the images are stored and worked upon or processed inside our brain that we are able to see these things. Any guess, anything that you could think?
So most of the time we know that size of that object, and if that size appear to be larger than what it is, then our brain thinks it is closer to us, and if that size is smaller than its actual size, our brain thinks it's far more from us. Or we can say that through blur also.
Okay, so what he is trying to say is most of the time we are aware of the size of the object. So brain knows about the object size, and if it looks similar to that size or bigger than that size, okay, and according to that it can think. But I believe the same object, if at all it is on a distance of 2 feet or it is on a distance of 20 feet, you are able to recognize the same object and also able to recognize its size. Tell me if I am wrong. Okay, one thing that let me ask you, how your whatever you have eyes, let me consider them as camera. So what do you think? What are they recording and how are they storing it?
Sir, we take pictures at different angles.
How is it possible? We have the fixed eyes.
So if object is fixed and it has been put in a three dimensional like then we can see the object in different angles so that we can visualize.
Okay, different angles means we have to move the camera as well. Means if the camera is mounted here
Yes,
in
sir.
on my body, I will have to take my body whole round the object, right?
Yes, sir.
Okay. But somehow, standing on this position only, I am able to recognize that it is a 3D object and it has certain depth. And the depth maybe the building is in front of me, then I have a cue that, okay, that is the building is maybe 10 feet or 15 feet or 20, whatever, approx something is coming in my mind. At least I am able to recognize that there is depth.
Sir, you were just asking height of object. How we can recognize that height of object?
Okay, you may be thinking about height. I am actually talking about depth.
Sir, sir, you are asking about how we are viewing it as a 3D object.
Yeah, something like this.
Means uh, whenever, sir, the front part of anything is bigger than the back part, I think the variations our mind is using them to give us a sense of 3D. The front vertices of any, I think, cube will be bigger in our eyes than its back vertices. That will, may give us the depth, and shadow also plays a role in it.
Okay. Am I visible?
Yes, sir.
Okay. Let us do an experiment. I have a pen here. this pen has a cap. Okay, I can see this pen and the cap. I can move it inside the cap. Simple, right? What you have to do, you have to take this pen and cap in your hand. You have to close one of your eye and then perform the same experiment. And you have to tell me what happened. Were you able to do it
with one eye?
with one eye?
With one eye, the object will be observed as a 2D object, sir. With two eyes, when we are seeing with two eyes, it gives us a sense of 3D.
Huh? Okay, it is definitely correct. However, let us think about this experiment first and we will start talking about it. What was the result of this experiment? You all
So with both I was able to do it at once, but with single eye, I need to try at different positions, and after 4-5 tries, I was able to do it.
Okay. So mostly this is correct. Mostly it happens. It may be a rare case that you were able to do it in a first attempt only. That was you can consider it as luck. So what is happening here is, as he can point out, that we have two eyes, and these two eyes, with the help of these two eyes, we are able to find out the depth information. As you were thinking about the different angles, these two eyes are only giving us the two different angles. Okay, from here we can see something, what is happening. This kind of thing we are calling it as a stereoscopic view. Okay, so what is happening here is, you have two eyes, and whatever your object was, so there is something that you can see with your right eye, and there is something that you can see with your left eye. Okay, so then by combining these two information, you are forming something in your mind how it looks like. Okay, so this information of two eyes gives us the view as well as the depth information also. Okay, so such kind of things, nowadays you would be seeing that your mobile phones are also coming with multiple cameras. I don't know the use of the third camera, but I understand the use of second camera. If at all we are having the second camera, then using these two cameras we have certain equations, and solving them we are able to find out the depth. Okay, so such kind of view is being called as stereoscopic views. Many a times now you will see some of the robots which are being built, they will also have two cameras mounted on them to give them a sense of depth along with the view. Okay, having this information, I wanted to start the transformation also. However, we will see the transformation in next class. So till now we have seen some of the things related to the 3D displays. Is there something else you want to discuss or you want to ask?